Good evening, everyone. I hope my screen is visible. So today in this session, we'll be discussing about the Wokwi simulator that we'll be using for the programming assignments, and uh, so will be programming assignments coming in your later weeks. So we'll be using this to perform the assignments. So Wokwi is a simulator. So it supports multiple development boards like Arduino, ESP32, STM32, and other things. And there is also a VS Code extension available for this, in which using which you can actually run the simulation in the VS Code itself. So if you prefer an IDE like that, otherwise it also has a inbuilt IDE where you can perform the write the code and perform the simulation. So for example, we'll create a simple blank project. So there are some projects that are displayed in here. You can start with the blank project. You can choose the required. Uh, so as I explained, you can also try this in your uh, own system. That would be better. So it's basically wokwi.com. There you can find this. So if I create a blank project with this Arduino, we will find the board coming here. And these are the files that are available here. And this is the library manager. So if you want to add some external libraries, you can actually search them and add it here. So you have to create an account to save your documents. If you want to save it there, you have to save it online in the website. You have to create an account in Wokwi. And also these files. Sketch.ino is the usual file, like the main program like file you use Arduino like program, Arduino code, and it's a main kind of thing. This diagram.json is something very special, uh, that defines the circuit diagram here in Wokwi. So this diagram.json is something that is uh, should be used by the Wokwi simulator. So here in this, if you change this diagram, you can see the values here change. Basically, this JSON file describes the circuit diagram and the connections and the different parts that are present in the diagram. As you change this one, you can also see the diagram changing here. Uh, yeah. So if you create a new file, let's create a README file. And you put something here. It's like a .mdv markdown file, basically some text-based file. It is, or this. And when you add a README file, so I'll just save it. Uh, so when I save it, you can see if you have a README, the contents of the README you can actually see here in a very rendered, formatted form, which is easy to read in some sense. So you can look up on more about the Markdown format if you want to learn more about it. And let's see how uh, to run a sample program and how to.
Sir, your voice is not clear.
Okay. Is my voice clear now? Hello, is my voice clear now?
No, sir. Some
noise is there.
Some noise is there.
Is it better now? How about
It
now?
is like very low, sir.
Is it better now?
Yes, sir. Yes, sir. It's fine now.
Sir. Yes.
Okay. So, yeah. I hope now my voice is clear. So I'll demonstrate how we can set up a simple circuit and run an Arduino code in Wokwi, right? So as you can see, this is the basic Arduino. These are called the GPIO pins, and we can GPIOs are like input-output pins. So let's create a circuit. You can add new parts from here. You can search for the parts that you will need to do this. So let's take a part like this LED, a simple LED. And for most of the parts, you will see a question mark with that part here. If you click that, it will lead you to the reference, which means it describes about that particular part. What are the attributes that is there to that part, the pin names of that part, and how it actually looks like in this diagram or JSON, and some examples that are using this part. So,
So this document from where you got it, this one?
so you can come from here with this
Okay,
question
sir.
mark that is present. Basically, this is Wokwi reference. You can search talks.wokwi.com. So basically the terms, and there are more details about using Wokwi and other things. There, this is the diagram reference part. You can also come here from the part. For Arduino board, you can come here and it will be describing about this one. What are the features that are implemented here, and some examples. Right. These are examples are also a Wokwi project like this. The sample example in this diagram.json, right? And you can see the diagram also consists like it describes about the different parts. So if I change the part, you can see the attributes of that part is changing, right? You can change the color of the LED. You can see that things are changing. So this diagram.json actually describes the circuit diagram in Wokwi, right? So it's an important file here. And the contents in the README that will be present here also as a description. And this is the main file, right? So in Arduino, there are two functions that we need to implement usually. Those are what setup and loop. So setup is like a starting code which just runs once, and then this contents inside this loop will be running forever. So that's how an usual Arduino code runs. So let's make a connections. So these are the GPIO pins, which means general purpose input and output pins. This can serve as input signals like pins receiving input signals or pins that's setting up like sending an output signals, either a high or low state. Right, a digital output. Basically, in the normal mode, it sends the digital output. It can be either set low or high. So we can connect this to that. So this is the positive tip of this. I'll just connect it to pin 13. Then this cathode, I can connect it to the ground. So now I have connected it to the pin 13. Right? So in the setup, so we are now going to implement the hello world of embedded C, which is called Blink. Blinking an LED at a certain interval. So to do that, in the setup, we usually first to use GPIO, we use this function like pin mode to set the pin mode to output. Pin mode, the pin number which is 13, output. Then after setting this up, we can set the value of that pin to high or low. That we can do by digital write pin number which is 13 and high.
Sir,
Yeah,
sir, what we are going to do?
we are
What
going
is
to we are going to blink this LED at an interval of 1 second. It will go on, off, etc.
okay?
So I'll implement this and I'll explain how it works. Right. So this pin mode here we are setting it to set that this pin 13 should be in an output mode. So there are certain modes in which we can set this GPIO pins: input, output, and input pull-up. Right, there are three modes, right? And there is also the input pull-down. We'll also look into that. So first, we'll do this. So here we are actually setting the pin mode to output. Since we are connecting that pin to the LED, we want to make it blink by setting that pin high. So when I set this digital write to high to the pin 13, so what happens is it will turn on. So the LED will blink. And there is another function that is already present in this Arduino. This is called delay. You can type milliseconds. So 1000 milliseconds means it's 1 second, which means for 1000 milliseconds it just do nothing and wait here in this line. It will wait. That's what basically this delay function does. So first I am turning on the light LED and then waiting for 1000 milliseconds, and then I am turning off the light by turning it low, and then I'm waiting for 1000 milliseconds in that off state. So I'm turning on. So light is on for 1000 milliseconds, and then I'm turning off. Light is off for 1000 milliseconds. And now to run this, we can use the simulation run button, and you can see the LEDs blinking, right? So anyone has doubt in how this works, or any doubt in this program?
So not doubt, this delay is there. No? That standard time is millisecond for one if is
Yeah,
there.
for delay, the input is milliseconds. For the relay function, accepts the value milliseconds.
Okay, sir.
And there is another function called delay microseconds, which will accept the input in microseconds if you want a smaller delay.
And one thing, so this delay can we add means can we enter delay in decimal values like point one,
No, no,
point
no,
zero zero?
it's integer.
Okay, sir. Okay, sir. Only means fixed value you have to add.
Ah, like in milliseconds, right? It delay
Yes, sir.
can
Yes,
the
sir.
least amount it can measure is 1 millisecond.
Okay, sir.
And if you want a lesser time amount than millisecond, you should use delay microseconds.
For highest time we can add like what is the largest value for delay we can give? 100 seconds like that we can give.
No, there is also a limit to that
Ah,
function.
yes,
So
sir.
let's see. So to know about the Arduino functions, there is this Arduino docs that is there. Uh, right? Uh, yeah. This is about the code. Just a minute. So Arduino language reference, you may have to look into it. So you can see this, right? The different functions that I use: digital I/O, which is digital read, write, pin mode. So these are the three functions. Like these are the two functions that I use now. I'll zoom in. I hope now this is visible,
Yes, sir.
and you can see all the related functions here. You click here, you can see what is the syntax, what are the parameters, what it requires, right? And there are this is the thing that you asked for. Yeah. Uh, yeah. Okay. This is about that one. So this is about the thing that the delay uses. Okay, we'll look into it like this. About this, we'll do that. So what this delay uses is it basically waits for this. Uh, you can enter, I think, as this one, the number as long as the unsigned long data type. Right, unsigned long is I think it's 8 bytes, 8 byte number, whatever you can give in the delay function. Right. So that many number of milliseconds you can give. Uh, the limit is the data type. Okay. And if you want to give more delay, you can also call delay multiple times, right? For example, Like if you want a very longer delay, but that won't usually happen, right? We don't want our system to be resting for a longer amount of time, which means when you use a function delay, the system won't be doing anything else. It will be just staying still for that many number of times, and we'll also see. So this notice about that. While requiring, when you want to do something for a very long time, we don't usually use the delay function to handle it. So those things, so we'll look into it as we go. So you can give the number as long as this data type has, right? The delay function. So yeah, that's it. Anything else?
No, sir.
Sir, I have a doubt.
Yeah.
Yes, sir. I just want to ask, like, what you have explained, like, are we supposed to perform the similar kind of simulation in our system?
Yeah, because you will be having programming assignments in week 6 and 7, which will
Okay.
be done in this.
Okay.
Okay, so it's better you can practice these things
Okay.
uh, from the samples to get an idea about how you can run these simulations in the system.
Okay. Okay. And one more thing, sir, though I don't know, like, whether it will be a correct forum to address this. Sir, I'm enrolled for this embedded C, but then again, that is not appearing on my dashboard. So, what is the correct procedure to, address it? I have written a weekly support, but then again, I didn't get any reply from them till now.
Okay, so it should be taken care of by the support. You can like uh, ask an update in the same thread that you used to
Sure, sir.
ask the support. Yeah.
Sure, sir. Sure, sir. Thank you, sir. Thank you.
Okay.
Excuse me, sir.
Yeah.
Do we use only this Arduino IDE for this entire embedded C program?
This is not Arduino IDE, right? This is Arduino core, but there is also different types of like Arduino is kind of a framework for writing embedded code, right? But we also have STM32, so we'll be also using the STM32 IDE to generate STM32 based code for it. And also there are ways in which like Arduino is a very high level framework for writing code, which is very simple like this, right? But we will be in later weeks, like in week 7, there are assignments which involve you to write low level code, which means you will be directly accessing the registers, which is also C. Arduino is essentially C++, right? You will be using other C++ without any Arduino kind of framework. You will be writing the code from scratch. Those kind of exercises, you will be modifying the registers to to do the same thing that I did using these functions that you will be doing using bit manipulation. Those will be also discussed there. So this is for intro. It's not like you only code with Arduino code, and the boards also will be different. So,
Okay.
so there are multiple IDEs for development. So you should understand the difference between the IDEs, frameworks, and development boards, right? Arduino is a framework, like a framework in the sense it has a setup and loop function, a format of writing C program, right? And there are different frameworks. STM Hall is another framework. It has a certain library. Arduino is actually a library in C, which actually has these functions and other functions that you use here defined there. It's a library, right? So we call it a framework, a way of developing applications. So similarly, there is STM Hall, which is another framework for developing things. And there is a AVR library, which is kind of a very low-level framework for developing a web application. It's also written in C. Right?
Yes, sir. Sir,
So the,
in that case, actually, I have done many Arduino related projects in my colleges, and I just wanted to go much more low level. Like, I need, like, if I, the end of the course, will I able to program any kind of chip using the MPLAB ID and something like that?
so we'll be going to all the details of how a compiler works, how to compile a code from scratch, everything will be going. Okay.
Yes, sir.
Yeah, we'll be going to the deeper level also. So you do. So since this is the first class, I'm just demonstrating how you can use this IDE. We'll be also showing you how you can compile this code locally in your system, and then we'll do the simulation for that project setup, how you can do that. I'll also discuss that. But first, for everyone who is new to embedded C, this is how we start, right? As weeks progress, we'll go deeper. Okay.
Okay, sir. Yes, sir. And one more thing, sir. Do we have the same the sessions, live sessions every week, about Thursday 8 p.m., sir?
Sorry.
No, sir. This will be the timing for the entire course, sir. There'll be only one live session for week, right, sir?
You can check this calendar, right? I think embedded C you have 2 live sessions per week, right?
Yes, sir.
One on the morning, Wednesday, and one on the evening.
Okay, sir. So, if it is it okay if we just attend any one of the live sessions, sir?
Both live session will be dealing different contents, so you might want to attend both. It is not like repeated thing.
Okay, sir. Then is it possible to get have any YouTube link for the live session, sir?
Yeah, every live session is shared like streamed in the YouTube only. There is a channel for embedded C in YouTube. I think that will be not sure that shared with you, but there is this channel. You can find it from this BS degree channel. It's under that BS degree channel. You can find this embedded C channel.
In dashboard.
Not sure dashboard. You might want to check YouTube for that. I'm not sure if the YouTube link is given in the course. Uh, I think someone shared the YouTube link here. You can check it. Yeah, yeah. So here in this, I think you can go to this channel, and in live you can see all the sessions streaming there. This was the yesterday's session, right? All the sessions will be streaming here, and you can see the previous time's live session also here. You can see this, right?
Sure, sir.
Okay. If you, I think someone asked about the low-level coding and things, you can see different frameworks of things that are discussed here. Yeah. So any doubt about this one? Shall we go to uh, some more coding with this thing? And I think we will be also having some practice assignments for practicing. For the first week, I want you to explore the IDE, try to uh, like open anything, like try out projects on your own. That would be very explorative rather than just doing the things that are given by us for practice. You can explore all these components, the boards that you can use here, the things are there. Uh, and similarly, as we do in this Arduino, we can also do the same thing in STM board. For that, we can open another new one.
Sir, one query, sir.
Yeah.
You told me from week 6 and week 7 we have to do, submit practice assignments and all. So that how we are submitting? Means in we are logging into our IIT mail ID in this Wokwi website or
No,
your.
no, 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 no. You do the thing here. You do the assignment here, and you download this as a zip,
Okay,
and
sir. We
we
have
will be
to.
uploading the zip file in the portal.
Okay, sir.
Okay.
Okay, sir. This is open source, right?
Yeah, so this is free to use. Wokwi is free to use, but there is a premium version. But for the assignments, you just require the uh, usual version is fine.
Okay, sir.
Yeah. You can also create a STM board like thing. So the STM board that is found in Wokwi also uh, this board is also Arduino compatible board in the sense you can see the Arduino pins D8, D4. These things are Arduino like things. So this set of pins are compatible with Arduino. You see this boards, right? These pins, these digital pins, 10 to 13, are also presented 0 to here, 13 and then ground like that. So you can do the same thing in both here and also here. So that's the thing. So what you have to understand is there are frameworks, there are different boards, and there are also uh, different IDEs. IDEs in the sense one is the Arduino IDE that you might have developed if you have a local
Uh,
actual board with you. Yeah. So if you had a local board, you would have used the Arduino IDE to upload programs into the thing. And
uh,
we'll also see how we can use the VS Code to do the simulation using VS Code as an editor for this. Okay.
Sir,
Yeah.
this all the coding what you're doing, we have to do it in a sketch.ino portal, right?
Yeah. So this now we are using the Arduino framework in the sense
Okay, in
that
for this STM, it is different. Our
okay, that's what I am said. Framework is different. Uh, you can use the Arduino framework in an Arduino board and also in an STM. Framework is which library you use to code, C setup and so which means we are using the Arduino framework to develop in an STM board. Here we are using Arduino framework to develop in an Arduino board. Arduino also a company like a manufacturer for this board. STM is also a manufacturer for the boards, but you can write codes using this framework. So Arduino also refers to a framework. Arduino also refers to an IDE. So you should understand the difference between the IDE, board, and a framework. Are you able to get what I'm trying to say?
yes, sir.
Sir,
Yeah.
what is the difference between ESP32 and STM32?
Again, the same. ESP32 is another development board created by a different manufacturer. These are development boards in general. It has a uh, microcontroller, right? This thing, an Arduino. This is the microcontroller. Like the Atmega chip is present in Arduino, and there is a circuit that is connecting all these things, power supply and stuff that is used for development. So you develop electronic peripherals, components, embedded systems using this. This is a development board, and there are different manufacturers. They develop uh, different development boards with the embedded, different embedded microcontrollers and stuff. Right? Just a minute.
Okay, sir.
So these are different manufacturers creating different development boards. These are different models of the development. And these manufacturers also create their own IDEs, which they feel it is easy to develop their boards in that IDE. That's why you have an Arduino IDE, which is an application that has an editor-like interface, and it is easy to like. It comes with built-in support for Arduino boards, right? If you want to use the Arduino IDE for an STM board, you might have to do an additional setup with it. So you also have a lab for embedded systems, and in that lab, you will be using an STM board with Arduino framework and STM framework. Like you will be using two IDEs and two different frameworks in the same board. So there are support for different frameworks in a single board. For example, this STM support both Arduino and this thing, but Arduino doesn't support STM thing, right? It's a very simpler board, so it supports only Arduino framework, and there is a lower level frame. So Arduino is developed on top of a library called AVR, which is developed to write C programs for this Atmega chip. Okay, so that's the low level thing, and Arduino is a higher level thing. Okay, so there are different frameworks, different boards, different IDEs. Some IDEs can be used to use different frameworks also, and some boards may support different frameworks, and also development using different languages and stuff. Okay.
So do we deal with microprocessors over here, sir?
No, only microcontrollers. These
Okay, sir.
are MCUs, microcontrollers.
Well,
Okay.
embedded C means only all we are dealing with microcontrollers.
Yeah. Okay.
Okay, sir.
Okay. Anything else you want to ask about embedded systems and things?
Sir, I have one question. And like I have studied about the microprocessors and controllers. In that course, like I will be like studying about the 8051, and we will be having like adding extra amount of memories and storing some variables over there. So do we able to connect like extra memory space and calling variables from those spaces like that
That's what the
memory?
difference between a microcontroller and a processor is. So a processor is just a processor. Okay. It don't have memory and that stuff. So you have to connect it externally. But in a microcontroller, everything will be inside it. Memory, the storage, and the processing. Everything will be in a single chip.
Actually, sir, I'm just asking about like if you want some more memory to add in microcontroller
That
unit.
you should do something using a peripheral. So there should be a peripheral, but not. It won't be as fast as like an inbuilt memory of a system. It should be like if you want to connect something to it, it should be done through a communication protocol. So there is a peripheral with a memory or a storage that is connected to this microcontroller, and this microcontroller should be communicating with the communication protocol. There are different communication protocols that you will be learning. Data transfer happen like this that it won't be like a very the communication works like that, right? It won't be like a what do you say a direct connection between the microcontroller and the memory, because microcontroller also already has a memory inside it. It would be like an external peripheral, like an external hard disk, you can say.
Do we do that in this experiment, sir? Like,
No,
can we do that in using Wokwi?
what we I think I don't think there are that kind of thing available here. There is a micro SD card available. So this is one thing, but I'm not sure which this you can access. Haven't used it yet, but you might check this out. So this has a file system, and this is how we connect peripherals. So this is certain peripheral, and I think this uses a separate this SPI protocol. So there is a certain protocol that is there, and data transfer occurs with that protocol. Right, and see there are how they are transferring this using. They are using some libraries to transfer the data. Okay. You might want to check this out. It won't be like a thing that is connected to the processor. It's an external device that is connected, and the data transfer happens using a communication protocol.
Yes, sir.
Anything else? Okay. Now let's see what are things that we can do with the this. You can also, as we can modify things by modifying here, you can also modify by changing this. See? You can do that also. Okay, if you change, edit it here, you can see the output. So if you prefer editing it this way, you can try that. So there's a certain JSON format that this Wokwi uses. So now let's see There are different ways in which we can do this. So let's connect 3 LEDs and try to write a program. Connecting 3 LEDs. So I'm connecting it to 12. Change the color of wires. Differentiate it. LED. Oops. Yeah, connections are done. You can also check the connections here, which are connected. Right, LED 2 is connected to UNO 12. This is 13, and this is connected to UNO 12. So you can verify the connection here also. Let's go. So now if I want to blink the LEDs in a consecutive manner, A, B, C. So on, other two off, on, other two off, on, the other two's off. So if you want to write a program like that, how will I write? So when we are dealing with multiple ports, the usual uh, practices are we used to define these things here. We can define this using hash define LED1 plus 13, LED2. So this program is about blinking 3 LEDs, right, in a certain way. So assume you want to change the, like you are rewiring this, you are using different pins for this LED. So if you make this statement and use this things instead of the actual pin number, since it is occurring in multiple places, if you write your code like this, when you want to change the connection, you just want to change here, right? Let's take defining a variable. This is for LED1, right? So now if I
Sir,
even if I change my connection, I just have to change the value in one place. Yeah. Any doubt?
LED 3 is 11.
Sorry.
Sir, pin number 11, LED 3.
Oh, this one. Okay. Yeah. So when you want to change the connections manually, you don't have to change the code in a different way, right? And you can also write code in certain way that these defines are coming from the compile thing. So you can compile it for, you can have the same code, but the definitions will be different when you compile. You can actually pass the defined values in the compilation command and see. So if you want to compile it differently with different pin numbers, this would be useful. Okay, let's that. So now if you want to, now our idea is this should be on, other two is off. This should be on, other two is off, and this should be on, other two is off. How will you write the code? Let's go through this. We should be setting all the LEDs to output mode. That's the first thing. So this happens only once at the start of the program. Great. So now all 3 LEDs are in output. Now, how about this? What should we add here? Any idea? How should we produce? Anyone? Any idea?
That LED 2 should be off, LED 3 should be off.
Where I should add that? In line number?
You after this be after this LED 1 high.
Yeah. So here, in the initial state, we'll define the state of each of the LEDs, which is LED 1, 2, 3. One is high, another is low, and this is also low. So,
Sir,
yeah,
one query, sir. In this code, if some error is happened, that error where it will be displayed?
here it will be displayed when you, if I am making an error, right? Here it will say.
Oh, okay. By default, it will show. You
When
don't
you
need to
run,
compile anything, huh?
here it is just this run, right? When you run, it will
Okay.
show the errors.
Okay. Okay, sir. Okay, sir.
Okay, now this is the first state, high, low, and low. And wait for 100 seconds. Then what we need to do? We have to change the state of the second LED to high and the first LED to low. Right?
Yes, sir.
Now this turn off this and turn on this. So this should remain the same. So we will leave that there. And then after this, or we should be doing here, we should be turning off the LED2 and turning on the LED3. Right? So now again wait for, and that is the, this is the other thing. You get the idea? So now let's
Yes,
try
sir.
running this. You can see that, right? How the code works. Is that clear? Any doubts?
Sir, can we use conditional statements for this?
Like what? Like what kind of conditional statements? Because we are not taking different paths right here. We are doing the same thing over and over again. Right?
Okay, sir.
Here we are doing this. These are the three states that we want to go, and we are doing that repeatedly. After this delay, we are again turning on the first light and turning off the boot. That's what happens. Right? Is it clear?
Yes, sir. Clear, clear.
So assume you want to create something different, a 3-bit thing. Like assume these are bits of 3-bit number. And what are the possible 3-bit numbers? From 0 to 7, right? We can have, what are different numbers we can have with 3 bits? 0 to 7. Right? In an unsigned setting. So assume you want to create a uh, code like this. Given a number, you want to turn on those LEDs that represent a binary, that is a binary representation of that. So there are certain ways in which you can do that, right? Okay, now I think uh, we don't go that way. We can go in a different way. Assume you have one more LED. So how will this code go? You need to do this again, and then you have to copy paste these things again. And how it will be? It will be difficult to do that because you are repeating the copy paste, right? So to write a better code, if you have a general array of LEDs, what you do? You should do keep an LEDs in the array, and you can use the for loop to do the repeated task. So let's do this in a different way. So for very large numbers, defining this individually might be okay. Sometimes it makes the code very big, right? So we don't want to do that. So an alternate approach would be this. You create an array with the numbers. So it's an integer array, right? So you can actually use a for loop here. N LEDs will be, number of LEDs is 3. And in mode, LEDs of I, set to output. Correct? And similarly, how we can do this with the for, this thing with the for. So there are 3 states, right? One on, others off. So to do that, for 3. So that corresponds to each of this. And the delay of this. We will be repeating this thing, same thing. So 1, 2, and 3. Right. So there are 3 LEDs. So this is also repeated, right? In some sense. So we can write an inner for loop. Uh, 0 to 3. And we'll make only that particular LED high, others low. So here we'll go with J, and when J equal to I, that particular LED will be high, others will be low. So it's basically uh, if let me just put that right, if I equal to J, turn that into high, else turn off the other LEDs and add an delay after this. These are not. This is also one way of doing this. I think for else you have to turn low. Let's try this. So now we can extend this program to any number of LEDs just by changing certain values. I think here also we can do in LEDs is equal to 3. Then we can just put in LEDs here. So if you want to add more LEDs, now our codes need not be changed much. Just define that here and put it here. You can even define that as a macro here like this. The preprocessors macro here, and if you want a compile time change, you can do that. Define these things here. So you notice that I'm using capital letters for this preprocessor macros. So So that's because like uh, it's good to follow this kind of conventions. So I usually follow snake case for variable names and caps letters for constants and defined state macros. This would be three, right? We can just use this. We need not need an integer over here. Just use that macro here. Right. That also. So now whenever you want to change the code, you just need to change this part. And this will work for any number of LEDs. Let's try add new LED. One. So now there are four LEDs. And now four we have to adjust. Add 10 here. And LEDs is 4. And it will work for 4 LEDs. So whenever writing embedded code, you should also think about what your code requires, how we can implement it. So for 4 LEDs, if you are doing that way, your code would look very long, and as LEDs increase, the difficulty, like the repetition of the code, will be also increased, right? So this is a kind of better way to do this generalized code. Any doubts here in this code? How it works or anything?
No, sir. So regarding this, only 14 GPIOs we can configure, right?
Yeah, Arduino board has only 14 GPIO.
And in the STM also same.
No, STM has actually many things, many boards. It in a card like these are certain boards, and there are also these boards, these pins that are available. It has more pins, but also has pins similar to Arduino. It's a very bigger
Okay,
thing.
sir. Here it is PB something, right? PB6, PB4 something.
The
Yeah,
okay,
P15, PA15 something, right? So in code, how we will configure it? Like yeah, there it is integer, right? Int LEDs 13. So pin number directly you can add. In this STM code also same pin number you have to add, or like PA something.
okay. Let me tell you this. So to use Arduino IDE, if you use Arduino IDE, yeah, you can actually use the PB12 and that values there, right? You have to you can put it like that. And actually, these pins are also will be having different names. For example, if you go and see the data sheet of this board, you will see alternate pin numbers for them. So there are two pin numbers you can use for this. The board is C0363136. This one. Oh, this is the driver. This, this is for yeah. This is the data sheet for that particular board. This is the MCU one. Let's see that. Okay, this is this board is 303136. So this is the board that you have in Wokwi here. Okay. And there are different series that are there. User manual. This one. Yeah. This is the one. See, this is the pinout view. These are the pin names here, and also these are the Arduino pin names, and these are the STM pin names. So actually, these pins have two names in some sense. The PS6 is equivalent to D12 in Arduino notation. So they provide support for both Arduino set of pins and also other pins that are there, right? So they have two names for some pins, these pins. So this is the Arduino name for this pin, and this is the STM name for that pin. Other pins only have STM names, just PB12, PB12. You can directly refer to in the code also. You can just put it like PB12 and things like that. Okay.
Yes, sir, but in PB12, like, uh, if int main we can't directly declare, like, so I have to like
No,
hash
no, no,
define.
no. Actually, they are numbers. So you will have okay. Uh, always is. So how they are actually integers only. What do you see? Like if you do PB6, it is not a string. The library actually has the integer value. There will be integer values corresponding to each other pins, which is defined in like the addresses. There will be addresses corresponding to each of the pin, right? Which will be
Okay.
defined in uh, a library, another C file, which we will import it. The Arduino thing there is right. It will have the number corresponding to that. So, for example, the high you use the output high. What is this? What
Logic
data type it is?
one.
What data type it is?
Uh, Data type
It's actually a number that
yeah,
is defined
yes sir,
like this in
high volt,
LEDs,
5 volt or 0 volt.
in LEDs. It will
Yes
be,
sir.
I think, either true, 0 or 1. It is actually defined as 0 or 1. High is 1 and low is 0, like that. So that PB6 will have a certain number, a certain address in some sense, address or number that we will use.
So there are LEDs because this flower bracket PB13, PB12, PB11 like that directly you can declare.
Ah, yeah.
Okay, okay, so that was my query actually because it is like the character and integer are together, right? So I thought whether directly we have to write integer
But you
or
should
like
also
together.
look at this manual. Like there are certain functions only available for certain things. I think this sometimes some we can see right here, which are the pins. What are the things that are available in set, every pins will be available here. For example, this PA2 is used for this reverse art. There are certain special pins are also there. Not every pin can be used for everything. Certain pins are meant to be used for certain use cases that you might need to look into this. So see, this is a timer, and this is for IO. You can see right. This is the Arduino P6. P6 is actually the Arduino D12, and it has also the default functions and some special functions are there. You might want to check those things before using any pin. So for simplicity, using the Arduino pins, it is fine. Okay. Here you can see the alternate functions that pin can do here. Okay. So this is the main feature which that pin can be used for IO basically. Okay. Anything else?
No, sir.
Okay. Actually, here the compilations and things happens behind the scenes, right? So what we takes care of, including the necessary libraries, everything it kind of takes care of. But when you use a local IDE, in Arduino IDE also, in lower level, the including libraries, pre-processing, compilation, all those things are handled by the IDE itself. That's why it was able to give a simpler interface. Just by clicking a button, you will be able to execute the code. But actually, behind the scenes, for each board, the compilation steps might differ, and those are actually configured. So this is about uh, output. For taking input, there are different things. Like there is taking input from sensors is there, which is what we call active input, which means um, the power is given to the sensors. Right? We give power to the sensor, and it gives a signal. And there are passive inputs, which is push buttons. Push buttons are passive inputs. Like it won't be given any power. It will be just connected to a ground and a pin. And we'll also see how we can read push buttons, and using push buttons can be uh, like uh, tricky in some sense. So for example, the push button uh, may look simple. So usually there is an option called bounce here. It's a very tricky to handle. So to avoid bounce, we for a simple program, a simulation, we can bounce and see how a push button works. So there are certain practice assignments that you have. Uh, we will be releasing that also from the next week, from week 2. So this week is just introduction about these what we can explore this. For next weeks, we'll be doing some practice exercises involving each of the components, input, output, and some concepts like non-blocking code and what polling is, and we'll see what is interrupts, different way of executing the code. So here the code execution is like do this once, do this repeatedly, right? But there is something called as interrupts, which is like instead of along with this main thing, we will be doing some short thing based on some events and things like that. So interrupt is like you press a button and then some other code triggers, and you will be doing that once and then coming back to the main loop. Those kind of execution flows are there, and different frameworks are also there. So far now, you can try doing this and explore the examples given in Wokwi for uh, these things. You can go to this Arduino Uno, and these are the basic examples Arduino Wing, and you can select a component like a simple component, a buzzer, and this is a sample code. There are many sample codes available here. So this may look very, what do you say, uh, complicated, but when you look into the code one by one, you could break down them easily. So you can try read the code, modify it a little bit. So that's how you learn things, right? So here actually also the buttons are assigned to the shortcut key ones. So I can actually play this thing by playing this to playing the clicking the buttons. So it's actually like a game. So a memory game kind of thing. It will play a sequence and we have to repeat the sequence. So this program is about that. Right? So it will play a tune and we have to play the same tune in the sequence, and then it will go for the next round. That's how this program works, and you can check out the other programs, the code, how they are defining things here. If you see this, these things are actually it has a pitch start, pitch, it's all the uh, which for the like the notes and corresponding frequencies are mapped together in this define statement, and it is using that. It is including that pitch.h, and they are using it like this. They're defining. So by looking at this code, you might get some idea about how each function does. And when you look at a new function, you might want to go and see the reference and what that particular function does. Okay. Okay. Does anyone want to try something like by sharing their screen? So maybe you can tell me something that you want to try. I will guide you to do that. Is anyone willing to do that? So just tell me what you want to try, and we will be doing this together. You will be writing by sharing your screen, and I will be guiding you.
Sir, I want to make a master and slave using ESP32 and
Not very complex
NRF24501.
for today. Today it is a beginner session, right? You are
Okay.
going to week uh, 6 or 7 like that.
So,
Can we do something simple so that others can also understand?
so it is simple, but I am using Arduino IDE, sir, for
Yeah,
this.
but you will be using libraries only, right? It
Okay.
is not about input output GPIO. Let's stick with GPIO today. You may not go far beyond that. Master slave things are the communication protocols, right? You are using some talking about communication protocols.
Okay, sir.
Sir, can you do just using that push button, that same LED one we can use, and when only push button works, only LED glows, and it
Yeah,
will go like.
we
I
can
want
do
to
that.
see how the push button in like here we are checked only for that LED input output, right?
Okay.
How we are feeding input and that I just want to know.
Okay. So there are different way of configuring these push buttons are there, and the most common way is pull up mode. So when you are connecting a push button in pull up mode, how you will connect is you will uh, connect it to the ground and to a pin. So like this. So if you see this talk string, see this is one rod in some sense, okay, and this is the another rod. When you press this, these two rods touch, and that's how the push button works. So connect one end of the wire here and the other end of the wire here, and when you press the button, these two ends will join. Right? That's the idea.
Okay, sir.
Now we'll connect one end to the ground. There's a ground here. I'm going to connect it here. And I'm connecting this to here. Two. So now two is our input thing. Right?
Yes, sir.
Okay. Now uh, let's instead of doing this, we will be turning on all the LEDs when the push button is pressed and turning off all the LEDs when the push button is released. That is the thing, right? So first,
Yes,
this
sir.
is this is fine, and we'll add.
So the right side of push button is not connected. It is open, huh?
Now we are using only this thing. One connection is
Okay.
fine, right? If you want to connect
Okay.
another thing, you can do that.
Another what?
Like using the same button, you want to give another signal also.
Okay.
You can do that.
Okay, sir.
So button pin I am defining as 2, and in mode input pull up. So before going to pull up, just let's see this, and I'll explain what the pull up is again later. So this is a passive input, which means we are not connecting it to any power source. One end is connected to ground and one end is connected to input. And this is in input mode, right? So there is no external power coming to this button. What pull-ups makes is it makes this particular GPIO pin high by default. It pulls it up. Okay, so this will be high by default. That's what the input pull-up does. So when you click this button, it will be high, and you press this button and it is shorted to ground. So what happens? The voltage here becomes low when you press the button. So when you press the button, it is shorted. By default, it will be high. That is what the pull-up does. When you assign it in pull-up mode, the pin by default stays in high, right? Input pull-up mode. Okay. And now, uh, so we want to read the state of that pin. So if you want to know whether which state this pin is, you have to read it. For that, digital read of the pin name. This is button pin, which will give you 0 or 1 or true or false like thing. So if the button is pressed, what will be the value there in the pin 2? If the
High.
button is no low,
Zero zero sir.
because it's pull up. If it is
Yeah,
not
by
pressed
default it is
only,
high.
it will be high. When it is pressed, it will be shorted to ground and it will become low.
Okay, but my question is, if you are using push button, by default you have to make any one pin high or low. It can't like directly you can't write it input because if it's like high,
Sorry.
push button if you're adding, here I'm not declaring it like pull up. Only I'm declaring as input. So will it work? Like or else we need to declare any one means by default we need to declare it high or low. Any one we have to declare it, right?
Not any one you have to declare. You have to declare pull up only.
Okay, sir.
So there are different modes of using this push button. And in this push button, in this mode, we are using that button in pull up mode. In pull up mode, one end of the push button will be connected to a ground and the other will be connected to a GPIO pin. But if you are using a pull down mode, then by default the input pin will stay low. But to make it high, you will be connecting it to a voltage source rather than a ground. Do you get it? If you want to connect a push button in pull down mode, by default it will be staying low and they will be making it up. You have to connect this to a voltage source, not a ground. So now this connection itself is in a pull down configuration, pull up configuration.
Okay, sir. I understood, sir. Understood, sir.
That's why
You're
we are
but
using pull up. So
okay,
if you are
sir.
just using input, the voltage here won't be stable. Like it will have a floating voltage, right? It may be
Okay, sir. I
high, it
understood,
may
sir.
be low, we don't know that. So that mode is used when you use a active input device, like a sensor, the plain input. Because the sensor will be giving the voltage signal, right? In that case, if you are using a sensor, we use the input mode. For a push button, when it is connected to a ground, we use pull up. And this is a pull up configuration, right? Did you get that?
Yes, sir.
Oh, so now to invert that logic of when a button is being pressed, we do this. So this means the button is pressed. When the button is not low or not high, it is pressed, right? So when the button is pressed, turn on everything, Mm, which is doing this. Turning everything to high. Else, turn everything to low. Now let's run this. So now it's not pressed. So everything is low. I'm holding it. I'm not just clicking, I'm holding it. Only when you hold, the lights will be on. When you release it, it will be off. So I'll stop this and assign a shortcut key to this one. So after that, if I use my one in the keyboard, it will be pressed. And I release my keyboard, it is released. See this?
Yes, sir.
Any doubts?
No, sir.
No. So you will be seeing this all the pull down configurations, other things in the practice assignments also. You can also look into some examples of how you can use these things. There are many concepts you might want to learn when you are going to this course. Okay. And there is a concept called bounds, like how to reel bounds, how to count the clicks, and those things will be also we discuss. Okay, this is fine, right? So if you have any doubts, you can ask. Yeah, someone raised their hand.
Yes, sir. Can I ask generic doubts?
Like something very not related to this course.
Oh, no, no, related to this course. I've joined a bit late, so is this like the first session?
Yeah, it's
Uh,
like the first programming session.
okay. No, no, I have few generic doubts about the course only,
Okay.
sir. So I wanted to know about like which textbooks you would recommend while we are going through the course apart from the video lectures. Any textbooks that can help us?
So mostly this in this while you deal with embedded systems, uh, the main things that you need to refer are the documentations and the data sheets. Those are the important things that you need to do when you uh, deal with the practical aspect of it. Because these are development boards and each development board has its own data sheet. So there is a data sheet for this chip that is particularly present, which is called AVR. Data sheet is there. So while programming that, you might want to look into those data sheets. And this is the data sheet for this. There are programming manuals. There are multiple data sheets and informations that you need to refer to. It's not about like to learn the concepts. Also, there are what you can say. Uh, Following the lectures to learn the concept is fine, but when you want to actually implement things, instead of books, you might want to refer the references, documentations, and the data sheets like this. So, for example, let me give an example. So, this is the data sheet for the Atmega GPU, right? So, I will be actually using this. You can see how GPIO works here, the circuit diagram of it, how it will work, and things like this, right? How you configure, which are the registers that you do the things. So these are the actual things that you might want to refer to, right?
Okay, sir. So this has I mean I believe this is like very specific to Atmega 320.
Yeah, this is very specific to Atmega 3.
Okay,
And you
320.
will find different data sheets. And I think this is where you can actually learn things in detail.
Okay. And follow-up question, sir. Like I have this STM Nucleo F446RE board.
Okay.
Like, is that are there any like I have it? I bought it for some other purpose, but I have it. So you were showing it around with C something. There was another model that you were
Yeah,
showing it.
mostly I think all the features will be supported. You can also use the F code, F series to do the exercises.
So would the professor also take use these boards only to explain the concepts and all that?
Uh, no, actually, the lectures won't be board specific. The lectures will be generic in some sense. Like he might use this Wokwi to demonstrate some code which uses this board, but the lectures will be in a generic manner rather than not specific to certain. In some lectures, he might use this uh, nuclear board to demonstrate things. But here in practical, like the programming point of view, we'll be using multiple different boards, STM, Arduino also. And functionality wise, the C series and F series don't have much difference. according like much different in the sense in context with what we are going to do. We are only going to do some general things that are supported across multiple boards. So that might not need that might not be the difference. The difference doesn't matter there.
Okay, just the generic sense of how actually programming a microcontroller is the basic point of the course, right? Like
Yeah, yeah.
not very board specific, but more about programming than a board.
Yeah, so to give you a gist of differences, we will be coding in different frameworks and different boards also. Because if it is just with one board, uh, it won't be very. It will be very specific, right? So to give you a general idea, we will be working with this STM and Arduino board, and also with different frameworks.
Okay. One more question. Like the C programming is prerequisite for this, right?
Yeah.
Like which topics are more that we need to brush up and practice more while we are taking this course? Like all the ones, like any specific inputs that you can provide us with, like as this is starting of the course,
Okay.
um,
So to brush up in the sense, we will kind of use most of the things that are there in C. Maybe dynamic allocation, no, because we rarely use dynamic allocation in embedded programs because the resources are fixed in some sense. So you might not need to revise dynamic allocation, but arrays, pointers, bit manipulation, basic preprocessor things like this, define statements that you might need to brush. The other things like basic data types, the very basics, loops, conditionals. I think that you need to check upon. I think from the C course, only the dynamic allocation part is not used in this. Other than that, most of the things like the basic loops and conditionals, uh, arrays, like simple application of arrays like this that we did, right?
mm,
Something like that. Structures, unions, we won't use. Structures sometimes we use. Like if the to make the program simpler, to design components in a structured way, we will use structs or objects in C++. You can also do that. Other than that, I don't think other concepts are required. Like most the concept that you can omit is the malloc and unions, those two things. Okay.
okay, sir. Okay, thank you. Any other suggestions that you would like give us, like as this is the starting?
Uh, the best way to learn is by doing things, right? So here, if you want to gain more in-depth knowledge about these workings, you have to practice coding and try doing some different things. Like if I want to do this with this, how do I do that? Experimenting is the key here, and also reading, look at the references. There are different references for how to you can use Wokwi. There is Arduino reference, how the different functions work. Where the functions can be used is also there. Right? Uh, and these are some communication. These are the communication protocols, and we'll also use communication protocols to communicate with some peripherals. So you can see an example of that. uh, Look, get started from examples. I think there are many examples that are available in the Wokwi also. You can search Wokwi website, uh, and also the other websites also might have some exercises there, some sample. You can try. These are the complex part. We'll go into this as weeks progress. So
Nice.
try doing simple things in this Wokwi. Is what I suggest for now.
So do we do this I2C communication part, all that? Like any electronics thing that we should know about?
The protocols.
Yeah, do we do that like in this course, I2C
Yeah, we will be
protocol?
doing that. You will be introduced to those concepts in the later weeks, and by the time, so week 6 and 7 are there, right? So till week 6 and 7, you will be covering most of the concepts that you need: GPIO, the communication protocols, interrupts, and things like that. So after
So
week
this,
6, you will be actually ready to do the coding exercises and stuff. We will be also doing some basic concepts week by week.
Oh, okay. Thank you, sir. Like, do we have this? Do we need to like know about any communication or
That will be
electronic
introduced to
stuff?
you in the course itself.
Oh, course. Okay. Thank you.
Yeah.
That is all. That is all for today. Thank you, sir.
I think we can stop with this for today. If you have anything to ask, you can ask. Otherwise, we'll end the session.
No, sir.
Thank you, everyone.
Yes, sir. Thank you, sir.